Hello. So in class, we left off at problem 2. This is section 5.4, by the way. I'm continuing this because we couldn't finish in class. We left at problem 2, Sarah and her aunt. Skip, you try 1. We're going to continue at objective 2, solve uniform motion problem involving current and wind. Okay. Number 3, the speed of the boat in still water is 8 miles per hour, and the current is C mile per hour, right? Here, the picture, this is the boat. So imagine on the left picture, the boat is going with the current. It's going downstream. Maybe I'll highlight it in red. It's going downstream. When the boat going downstream, is the current kind of helping the boat moving forward a little bit too, right? So the speed of the boat going downstream will be its speed, which is 8, plus the speed of the current. If you're going upstream, so here is still the boat, but then you're going upstream, you're going that way instead of down that way, right? You're going up against the current or against the wind. Then the speed of the boat is equal to the speed of the boat minus the speed of the current, right? Imagine when you ride a bike against the wind, it's kind of hard to bike, right? It's kind of getting heavy because the wind have a force against you. So same thing with the boat. If it's going upstream, the current have that force against the boat, make it go slower. Number 4, a river cruise boat sails 60 miles down Mississippi River for 4 hours. It took 5 hours to return. What is the rate of the boat in still water and the rate of the current? So let's see, the distance is 60 miles. Here I have the formula R times T equal D. Right. Distance is 60 miles. Let me highlight that. 60 miles. And doesn't matter going downstream or upstream, is always 60 miles for the distance, right? It took, let's see, if it go downstream, it took 4 hours. So if it go downstream, it took 4 hours, so 4. If it go upstream, it took 5 hours. Okay. And what's the rate? Remember, the rate for downstream is the rate of the boat plus the rate of the current, right? So here it's gonna be downstream, the rate of the boat, we call it B. Remember, so right here, it's define the variable B be the rate of the boat in still water, and C is the rate of the current. Right? So for the rate downstream will be the rate of the boat plus the rate of the current. Upstream will be the rate of the boat minus the rate of the current. Now we have 2 equations. See, we have 2 equations. So we have, remember, we have R times T equal D, right? So that means all I have to do is multiply all of these together horizontally. Okay. So the first equation I have B plus C times 4 equal 60. And then the second one is B minus C times 5 equal 60. Before we solve using elimination or substitution, I suggest you distribute the 4 and the 5. Right? So distribute the 4 and also the 5 down here. So here I have 4B plus 4C equal 60, and then blue 5B minus 5C equal 60. I'm going to use elimination, okay, and I'm going to eliminate variable C. So I have 4 on the top, -5 on the bottom. LCD is 20, right? So on the top, all I have to do is multiply the top by 5, multiply the top by 5, and multiply the bottom by 4, because I need 20 and -20. Now I have a new set of equation. The top one, if I multiply by 4, I have 20b plus 20c equal 300. And then the bottom I have 20b minus 20c equal 240. Now we can add them together. Positive 20c and negative 20c is gone. Add down 20b plus 20b is 40b. Maybe I'll go, oops, I need to keep with the same color. Now let me fix it. Let me fix this. Oops. Okay. All right. Now 20c and minus 20c is gone. And I have, add now I got, maybe I'll go over here. I got 40b equal 300 plus 240 is 540. Divide both sides by 40, b equal, let's see my calculator on my phone. 540 divided by 40, 13.5. And because B represent the rate, so the units will be mile per hour. So the speed of the boat is 13.5 miles per hour. Now we have to find the speed of the current. We can substitute into either this equation or this equation, whichever one you pick. Okay, I'm gonna pick the red one. So now I got 4b plus 4c equals 60. Substitute 13.5 for b. 13.5 plus 4c equals 60. 13.5 times 4 is 54. Plus 4c equal 60. Subtract 54 both sides. Yeah, I'll write it out for you. Subtract 54 both sides. I got 4c equal 6. Divide both sides by 4. C equal 6 divided by 4, 1.5 miles per hour. So the speed of the current is 1.5 miles per hour. Number 5, Jason paddled his canoe 24 miles upstream for 4 hours. It took him 3 hours to paddle back. What was the speed of the canoe in still water and the speed of the current? So again, they asking for the speed of the canoe and the speed of the current. So I'm gonna say, let C, no canoe, I wanna say K. Let K be the speed of the canoe. And then C be the speed of the current. And it's mile per hour. The unit is mile per hour. Right. So the distance is 24 miles back and forth. Right. So 24 miles, distance 24 miles for both. Times upstream, it took Jason 4 hours. Right. Upstream is 4 hours. Downstream is 3 hours. Paddle back downstream is 3 hours. The rate for upstream is gonna be, remember upstream is subtract, downstream is addition, right? So upstream is gonna be the canoe minus the current. Canoe minus the current. Canoe, I say K minus the current, which is C. And downstream is canoe plus the current. The speed of the canoe plus the speed of the current. All right, now we can set up our system of equation. At the first one, I have K minus C times 4 equal 24. The reason I'm times because here we have rate times T, R times T equal D, right? And then the bottom one, I have K plus C times 3 equal 24. Distribute 4 and then 3. I have 4K minus 4C equal 24. And then we use blue, 3K plus 3C equal 24. I'm going to eliminate C because it's the sign is already opposite. All I have to do is multiply top and bottom by some number, right? LCD is 12 because I got negative 4 on the top, positive 3 on the bottom. I need it to be positive 12 and negative 12, right? So I'm going to multiply the top by 3 and the bottom by 4. The new system of equation, I'll write down here. 3 times 4 is 12K. 12K minus 12C equal 24 times 3 is 72. And then the bottom one, 4 times 3 is 12. 12K plus 12C equal 24 times 4 is 96. Now we add. That is gone, right? Now I have 12K plus 12K, that's 24K. 72 plus 96 is 168. Divide both sides by 24. K equal 168. Divided by 24 is 7. So the speed of the canoe is 7 miles per hour. Box this up. Now we're going to find the speed of the current. Speed of the current. I'm going to use the red equation. I'm going to use this one. So now 4K minus 4C equal 25. 4K, which is 4 times 7 minus 4C equal 24. 4 times 7 is 28 minus 4C equal 24. Subtract 28 both sides. That's cancel. I have negative 4C equal minus 4. Divide both sides by minus 4. C equal 1. So the speed of the current is 1 mile per hour. Pretty slow. If you want to try it out yourself and you try to, I'll leave information here for you. If you want to practice it, so here 45, here yeah. You're going to try it out. All right, problem 6. Now we talk about the wind, right? An airplane travels at a constant speed of X mile per hour, and the wind is W mile per hour. So they call the speed of the airplane is X, and the speed of the wind is W. On the left picture, the airplane is going with the wind, going in the direction of the wind direction. So again, with the wind, we're going to do addition, right? So it's going to be X plus the speed of the plane when traveling with the wind, or they call it tailwind, is X plus W. when the speed of the plane when traveling against the wind is going to be x minus w. It's kind of similar to upstream and downstream. Okay, let's see some problem. A small jet can fly 1,095 miles in 3 hours with a tailwind, but only 987 miles in 3 hours into a headwind. So again, the winds mean headwind. Find the speed of the wind and the speed of the jet in still air. The speed of the jet with the tailwind and the speed of the jet against the headwind. So here they let J be the speed of the jet in still air, and they let W be the speed of the wind. Okay. So again, we have the same formula, R times T equal D. Distance is the same, right? Back and forth is the same distance, is always 1,095 miles. The times for tailwind is 3 hours. It took 3 hours for the time in tailwind. So 3 here. And then headwind is also 3 hours. Oh, I'm so sorry. We have two different distance here. In the tailwind, the distance is 1,000 miles and 1,095 miles. In the headwind is 987. So sorry about that. And the time is 3 hours. The rate of tailwind, then the tailwind is going with the wind. We're gonna do addition, right? So it's gonna be J plus W, and for the headwind going against the wind, it's gonna be J minus W. Now we're gonna put this into a system of equation and solve. So I have J plus W times 3. Make sure you put the parenthesis around it. Equal 1095. And then the bottom one, I have J minus W times 3 equal 987. Okay. Distribute the 3J plus 3J plus 3W equal 1095. And then I got 3J minus 3W equal 987. Three J and minus 3J cancel. 3J plus, I'm sorry, 3W and minus 3W cancel. 3J plus 3J is 6J equal 1095 plus 987. So 5 plus 7 is 2, 1, 8, 0, 2. Divide both side by 6. J equal 20 divided by 6 is 3. 28 divided by 6 is 4. 42 divided by 6 is 6. So 346 miles per hour. That's the speed of the airplane in still wind, right? Oh, 42 divided by 6 is 7. Sorry, 7. And now we're gonna find the speed of the wind. I'm gonna use this equation. So now I got 3J minus 3W equal 987. 3 times J is, the speed of the jet is 347 minus 3W equal 987. 3 times 347 is 1, 2, 12, 14. 9 plus 2 is 11 minus 3W equal 987. That's 10. 9 plus 1 is 10. Subtract 1041 both sides. Begins use your calculator. It's just faster for me to do by hand than just reaching out for a calculator. So this one cancel. I have negative 3W equal 1041 minus 987 minus 1041 is minus 54. Divide both side by negative 3. W equal what? 24 by 3 is 18, right? Mile per hour. Oops. It's okay. I meant to do in blue. Make sure your answer has to make sense. All right, last one. A small jet can fly 1,072 miles in 4 hours with a tailwind, but only 848 miles in 4 hours into a headwind. Find the speed of the wind and the speed of the jet in still air. The speed of the jet with the tailwind and the speed of the jet against the wind. Oh, I think let me go back to number 7. We found the speed of the jet in still air, which is J, and then the speed of the wind, which is W, but we have not find the speed of the jet with the tailwind, right? So there's one more. So I think I missed some. So tailwind here is tailwind mean with the wind, right? Let me write it properly. Speed of the jet in tailwind. I don't have enough space, so I'm just gonna say speed in tailwind. So tailwind is what jet plus current, right? J plus C, which is, maybe I'll go it down. J is 347 plus C is 18. So that will be 365 mile per hour. So that's the speed tailwind, and the speed in headwind is J minus C is equal to 347 minus 18 minus 17, 329 mile per hour. So don't forget to answer that question. So they're asking for 4 things here. Remember, they're asking for 4 things. Speed of the wind. Speed of the wind will be in blue. Speed of the wind, which is C right there in blue. Speed of the jet in still air, which is J. And then speed of the jet with tailwind and speed of the jet against the wind. So 4 things. Right? Okay, number 8. A small jet can fly 1,072 miles in 4 hours with a tailwind, but only 848 miles in 4 hours into a headwind. Find the speed of the wind, the speed of the jet in still air, the speed of the jet with the tailwind, and the speed of the jet against the headwind. So similarly, we're going to fill out a table and set up our equations. The distance with tailwind is 1,072 miles. Headwind is 848. Time in tailwind is 4 hours. In headwind, also 4 hours. The rate in tailwind will be the rate of the jet, which is J, plus the rate of the wind. Maybe we should define the variable. And then headwind is J minus W. Now the system equation is, I have J plus W times 4 equal 1072. And then I have J minus W times 4 equal 848. 848. Solve the system of equation. Distribute the 4 on the top. I have 4J plus 4W equal 1072. And then on the bottom, 4J minus 4W equal 848. That's cancel. Right? When we add, that cancel. 8J equal, if you add it together, 1072 plus 848, see 0, 2, 9, 1920. Divided by J. I'm sorry, divided by 8. 19 divided by 8 is 2. 32 divided by 8 is 4. So 240 miles per hour. So the speed of the jet is 240 miles per hour in still air. Right? In still air. Now, I'm going to find the speed of the wind, which is W. So now I have 4J plus 4W. I'm using the red equation equal 1072. You can use the blue equation if you want, okay? You get the same result. 4 times J, which is 4 times 240, plus 4W equal 1072. 4 times 240 is 0, 6, 960, plus 4W equal 1072. Subtract 960. I got 4W equal 1072. Subtract 960 is 112. And then divided by 4. W equal 28 miles per hour. So the speed of the wind is 28 miles per hour. And again, don't forget, you have to find the speed in tailwind and the speed in headwind. Right, so the speed of the jet in tailwind, which is equal to J plus W, which is equal to 240 plus 28. And the speed in headwind is equal to J minus W, which is 240 minus 28. 12. So here is 212. I'm sorry, 212 in the bottom. I subtract 212. And then here, this one is 268. Mile per hour. Mile per hour. Okay. If you want to try the you try yourself, get some practice. Yeah, I'll give you the you try problem. A commercial jet can fly 1,320 miles in 3 hours with a tailwind, but only 1170 miles in 3 hours into the headwind. Find the speed of the jet. In headwind. In headwind, when it's subtract, right? J minus W. Okay, all right, good luck.